Hi class, in this lesson we're going to take a look at set operations, which is section 2.3. And in this section, we're going to be taking a look at doing things with the different sets that we've been taking a look at so far. And the first type is we're going to be looking at union, and we're going to be working with the word or here. And intersection, we're going to be looking at the word and. Now the nice thing about intersection is that its symbol looks like an upside down A if you drew a line through it, but it's really an upside down U. And so union works because it looks like a U. And intersection, obviously the word intersection doesn't look like the upside down U, but it looks like the word that it means, which is and. So hopefully that helps us out. But so let's talk about it for a minute here. Union of C and S means anything in this whole Venn diagram would count as the union. So I would say it's C, set C, or set S. So anything that's in either one of them. So for us, it would be that R2, the R3, and the R4. Now what we're going to see is that those are different regions. So this is region 1, that's outside the Venn diagram. Region 2, region 3, and 4, respectively, are inside here. So we're going to be talking about regions in a little bit as well. So let's take a look at intersection. Intersection is the and this is what they have in common. So the intersection of C and S would be only this region 3. So the intersection of C and S is only region 3, because that's what they both have in common. It's the thing that is in set C and in set S. So let's see how this plays out. So we're going to be, here's the actual definition of union. If you want that, so you can come back. So again, the keyword there is or. So pause and read it if you like. But here, down here, it says the union of this set. We've got set A, set B. The union of set A and B here, you would write like this: A union B would be equal to, and then you open a set, and then you put all the elements that you see that are in both. So I see the 3 is in both. I see the 6 is in both. And that looks like it, but it doesn't matter because union is or, so everything that is in either set goes in your overall set. So I count each element once. I got 1, 2, 3, 5, 6, 7, 8, and 9. That is the union of those two sets. Now notice I circled the 3, and I only wrote it once. I circled the 6, because it's in both, and I only wrote it once. You only write each element one time in the union. So this is the word or. So we write an overall set of anything that is in either one of the two sets together. So we're joining the two sets together there. So here we've got a very large list, and we are to find our union of the following pairs of sets. And what happens here is they're saying that this whole table has the shortened names for each thing: bicycling, calisthenics, and so on. And so they're saying set E is the set of activities that need special equipment, and then set L is the set of activities that must be done in a special location. So YO, hot room yoga, needs a hot room. And so we're going to be looking at the union of that and the intersection of that. I thought I had something that said the union. But so the union of set E and set L is going to be every element of both of them. So I'm going to say RT, BI, EL, TE, and then I'm going to write the ones that I haven't written yet, like I haven't written YO. But I've already written EL and I've already written TE, so I don't need to write them again because they end up in both of them. So you write every element one time, and that is the union of the two sets. Now we're going to take a look at intersection, and as I talked about the first slide, you're using the symbol, it's an upside down U. It looks like an A, and again the keyword is and. It's the numbers that are in A and B. Now if there is no intersection of them, then we would say it's the null set, or there's nothing. They are called disjointed. In other words, they're not overlapping at all. It would be an easy way to say that is here set A and here set B. And my Venn diagram is there's no overlap, there's no connection between the two. So that's a good visual for that. So the intersection of this is set A and this is set B. I don't know why they weren't written separately there, but there we go. So this is set A, this is set B. The intersection of these two would be to write everything that is in each set once. And oh, that's right. I had these earlier in the PowerPoint. But here's the 3, they're in both, and here's the 6, that's in both. And so all I write is the 3 and the 6. Those are the numbers that are in actually both sets. So this is the intersection of set A and set B. Again, keyword is AND. So we can take a look at a larger list that we had earlier, and we've got these same two sets, and our job is to now find the intersection of set E and set L. So now, we kind of showed it earlier, but here EL and TE appear in both sets. YO and RTBI do not, so our job is to write a set with just EL, TE, and that's it for our intersection of those two sets. So again, hopefully this big long list, it really didn't mean anything to us. We already are given the sets in a short form, and so we work from those sets to get our intersection or union, whichever the question is asking us for. So I'm going to go ahead and break here and make a new link.